Welcome to this third and final video on the prologue lecture for computational applications that's about classes. Here we will be importing and using a module of classes. In this case, you need to make sure that the user-defined module commonfunctions.py is located in the same folder as this notebook. Open it up and examine its contents. We will play with this module in the classes it contains below. So on the hub, you should make sure that within the folder that you have for computational applications, wherever this prologue lecture notebook is, that you put this commonfunctions.py file. And if you open it up, which I already have it open here, you can examine its contents. In this module, it's using the matplotlib.pyplot function, and it's using NumPy. What this module is doing is it's using a function template for an object that is then subclasses for different things like polynomials, sine functions, cosine functions, logarithmic functions, exponential functions, and that's it. You can put some more in there as well. But what we're doing with these functions is we're creating them very much like what the polynomial activity was having you do, where they are going to have three specific method attributes. There's the initialization to initialize the object. There's the idea of evaluating that object. The reason you have functions is so that you could evaluate them at some array of inputs. And then we have the ability to plot these functions. So this was inspired by the first activity in this notebook about a polynomial object. But here we're expanding it to show how you can do things with sine and cosine. And you're free to play with this quite a bit. And there's a suggested activity for you to create and plot several instantiations of each of these classes of functions within this module. But the point of this is to show how you could create a module and you could put your classes inside the module, and then you can access and use that information. Because classes are really useful objects, and you find yourself often wanting to do object-oriented programming and create classes when you're starting to do pretty sophisticated things, and you're going to want to use that in a variety of code. So I'm going to import the common functions module as CF. I write it just like this as long as commonfunctions.py is located in the same directory, the same folder as this lecture notebook. And so when I run it, common functions is now imported as CF, which means I can create a polynomial using cf.polynomial, right? Because polynomial, if I come here, polynomial is a class that's within here, and it's inheriting from this function template, meaning it has this plot command attached to it. And the thing that I have to change for each of these functions is how is it initialized and how is it evaluated. So the way it's initialized for a polynomial is I give it a set of coefficients, and when I evaluate it, I just loop through those coefficients and multiply by x raised to the power, where that power is determined by what's the index of the coefficient. This was discussed in the first activity about polynomials in this lecture notebook. So I'm passing 0, 0, 1. So the first constant in my polynomial is 0, the second constant is 0, and the final constant is 1, which means this is the polynomial that is x squared. And so I've now created my poly, which is a polynomial function based on this instantiation of this object. And now I can plot it using matplotlib widget, and I can do mypoly.plot with the -2, 2 here. This method is inherited from the function template class. And look what happens when I run it. I plot the polynomial x squared, which has that nice look to it, right, of a parabola. I can use things like these question marks or help to understand what else is in my module that I've imported, the common functions as CF. So sine was in there. In fact, I'll just show, I'm going to create a new code cell here and say CF dot, because it's an imported module. And if I do tab, I can see that I have a cosine class. I have these exponential, logarithm, there's NumPy, there's other things that are within this CF that have been imported. So I'm going to look at sine. And when I look at with this question mark, look what it does. It's showing the initialization signature. And if you say, what is that? CF.sine omega equals 1, A equals 1. And it has the doc string and this initialization string. If you come in here and you look at sine, it's saying, this is how this class is initialized with omega equals 1 and alpha equals 1 as default values. So that's an initialization signature. So if you initialize a sine function with It has some default values for what the frequency omega is and what the amplitude A is. All of this information in terms of the attributes, how it's documented, is following best standard practices in terms of what these values are, like A and omega, and what they mean as an integer or float, and it's the amplitude of the sine function or the frequency. This is all described here, and this is following the type of documentation standards that I'm showing for the polynomial activity that was near the front of this notebook, near the top of this lecture notebook. You can also say help cf.sine. Notice the difference in the outputs. If you use the question mark here, this is printing something just about sine, whereas if you say help, it will point out that this sine object is inherited, and it inherits methods from function template like plot. This produces more information than just having a question mark here. I'm just showing you this so that you can understand that there's different ways to ask for information about objects when you start putting them into a module that you're importing, because eventually your modules can get pretty large and contain a lot of objects, and you might just want to have easy access to the documentation without having to open up the file and scroll around and find or search for where all this information is and read it in the raw source code. You just might want to read about it in a different format within an interactive notebook environment. But at any rate, I will create a sine object, my sine, cf.sine. I'm going to say omega 2 pi. I'm using the built-in constant of pi within NumPy with an amplitude of 5. So this should be 5 times sine of 2 pi x. And if I look at plotting that between 0 and 1, I should see what looks like sine of 2 pi x. And from 0 to 1, it passes through one entire period. Notice within the plot function here, I'm giving it the xmin and the xmax, and I'm overriding some of the default values that are within that method attribute, because in that method attribute, when it inherits, you give it an xmin and an xmax. There's no default values. You have to specify the range of x values that you want to plot and the function on. And then it defaults a figure number, it defaults a number of points for the plotting, and it defaults a color and a line style. You can use the names of these variables, these parameters, to override the default values. This is also discussed and shown in the polynomial activity. I could look to plot this. Let's say, imagine I plot this from 0 to 10. I'm using 100 points. So it starts to look a little rough. If I want to use more points, that was the in parameter. And now these things don't have to be in order at all because I'm keywording them. So maybe I use 500 points, and it looks much smoother. So that's just some ways that you can play around with this. I'll just bring it back to what it was. Play around with the object. That's it. This is a very short video. I just wanted to show you how you could import a module containing classes, how you could inspect the objects of those classes with some help functions, and how you could instantiate those classes and interrogate them. I suggest you do this with the other functions that are in here. Play around with them. Maybe edit this common functions.py. You could do it so there's differentiation and other types of methods within these various classes, similar to what we did with the polynomial activity. It's really up to you. And then just remember to have your summary activity at the very end. Thanks for listening.